RCAST. Welcome to the Climate and Coordination RCAST, where every week we'll be discussing topics related to all things climate change and RChain's role in the solution. We will be discussing technologies that can adapt and coordinate massive amounts of data like never before, forming social architectures that grow collective intelligence, sharing and evaluating data planetarily, all while maintaining personal privacy and personal data ownership. A new decentralized economy is forming as we move from the third industrial revolution, digitization, to the fourth, decarbonization. By building a co-op, built on a correct by construction, concurrent, scalable solution, RChain is structured to build out the new technology that will be required for a flourishing regenerative planet. Please join us on this journey.
Okay, well, good morning and welcome to this week's iteration of the Climate and Coordination RCAST. So today we have a variety of stories to talk with you about, and I understand that Greg might be involved in the latter part of the conversation as well. So we'll just get started and see where the wind blows us, as it were. Okay, well, my two articles today are from the same publication. I have to say, I have been reading a lot from The Guardian recently. The Guardian is such a good publication. They report on a lot of stuff happening in the US, but they're, obviously not based in the US. So I just think it's a cool, objective source of information. And they always do really high quality reporting. So here's the first story. This is from The Guardian. This is from their conservation section. From Fiona Harvey, who's an environment correspondent. This is from Wednesday, October 14th, 2020. So just about 2 weeks ago, headline is "Rewild to Mitigate the Climate Crisis, Urge Leading Scientists." So this is a great story. This is for people who are interested in the rewilding efforts, which is basically about kind of letting it's about restoration of, it says, degraded natural lands, but I think it's also, I've heard a lot of environmentalists talk about it as being kind of a let it be, kind of leave it alone kind of effort to see how nature kind of repairs itself. And the rewilding aspect also talks about sort of reinstating the natural diversity to an ecosystem. So I'll just read a little bit here because this is a great story for anybody who's interested in learning more about these efforts from a global perspective. It says, restoring natural landscapes damaged by human exploitation can be one of the most effective and cheapest ways to combat the climate crisis while also boosting dwindling wildlife populations, a scientific study finds. If a third of the planet's most degraded areas were restored and protection was thrown around areas still in good condition, that would store carbon equating to half of all human-caused greenhouse gas emissions since the Industrial Revolution. And it says the changes would prevent about 70% of predicted species extinction. So this is a great way. A lot of people don't really think about the environmental catastrophe we're in as being like sort of twofold, but it really is. There's the temperature side of it, which is the climate side, and then there's the extinction side of it, which is the biodiversity loss. So for example, if we found a way to magically stabilize the temperature on Earth, but we still go on, destroying all these habitats, then we would still have an extinction crisis, even if we didn't have a climate, like a temperature crisis. So this kind of gets at both of those things, which I think is really important. It says right now that only about 1% of finance devoted to the global climate crisis goes to nature restoration. but nature-based solutions were among the cheapest ways of absorbing and storing carbon dioxide from the atmosphere, with the additional benefits being the protection of wildlife. And anyway, I just thought this was a really great piece. There's a bunch of links in here that show the research that verifies these claims, and also it says there was a senior lecturer in biodiversity at Manchester Metropolitan University said this analysis indicates that we can take massive strides towards mitigating the loss of species and increasing atmospheric carbon dioxide, well, that's interesting. It says increasing atmospheric carbon dioxide. I think he means decreasing. I think this is a typo. But anyway, by restoring just 15% of lands, which is, so I guess the goal is to try to restore 15% of ecosystems around the world, which I think is very doable. So anyway, Daryl, do you know about any rewilding efforts in Canada, or have you heard of this strategy before?
I heard about it actually through Steve Ross Talbot a few weeks ago on this call.
Mm-hmm.
And he was encouraging me to do that in my backyard. So I'm going to
That's
do
right.
that in the spring. I'm going to experiment.
Yeah, I remember that. Yeah, right. I remember that.
Yeah, but it does seem like it shocks people at how quickly life comes back after forest fires and after kind of other kind of devastating things like the oil sands project in Alberta. It always people are kind of like, wow, nature's really resilient. It sure can spring back when it needs to.
Well, it really wants to thrive,
Yeah, exactly.
And it's been, some of these plants and animals have been around for millions and millions of years. So it's like they've had practice, surviving cataclysmic events.
Yeah, but
Although,
the point you made about how there's the CO2 level global warming issue, but there's also the extinction issue, which are most of the time interconnected, but
yeah,
there's some that aren't completely interconnected, but are still a result of an excess of human plundering and
exactly.
and a lack of understanding of us as humans, of understanding the big picture enough to actually work in concert with each other to do something about it.
Right. Yeah, exactly. Yeah. I mean, that's the thing, is that not every action that is a biodiversity loss action impacts the climate, and not every climate situation impacts biodiversity loss, but I think most of them do. They certainly accelerate one another, right?
Mm-hmm.
For example, like the oceans get hotter, the coral reefs die, the fish don't have food, the fish die, right? So that's where it's like it gets hot, then the animals die. But yeah, it's really important to kind of look at the entire equation, which is why, sometimes Greta Thunberg really, in her speeches, she gave a speech, I think it was at the UN last year, she was talking about, the extinction part of it just alone. And she started to cry, and it was really moving. And she got some of the people in the audience to start crying because, obviously human beings are sympathetic, creatures. And usually if we see somebody in pain, we tend to feel it as well. But it was really profound, because it is really sad what's happening. But I also think there's a lot of hope if we try to rewild areas that we can rewild. And the article also talks about farming and how we can convert a lot of farmland to be rewilded, but then also just make the farming practices better. So that would mean that we could still feed everyone and save water and give some of the land back to the earth. You know what I mean?
Oh man, speaking of farming practices, I mean, one of the things that I've been thinking about while you've been talking is the scourge on the planet known as Monsanto, and the crazed ideas
Absolutely.
they have with the destruction of bee populations. They literally were developing. I have a feeling they've dropped this project, hopefully, but they were literally developing bee robots that could replace the bees that they're killing in order to pollinate.
Oh, Christ.
Yeah. But yeah, Monsanto, it's hard to overestimate the damage that corporation has done. I mean, you look at the plundering of the Brazilian rainforests right now, and the reason for it is to grow soy, Monsanto soy, in order to feed cattle,
Right.
to feed North American and Westerners' desire for beef.
Right.
Which is insane.
It's totally insane. Yeah, I mean, we have a lot of work to do, but I do see hope in these efforts to rewild, and every piece of nature that is saved, makes the next piece stronger. You know what I mean? So we just have to figure out how to save these places, and I think that we can. So there is one more article, if you like. This is also from The Guardian, and actually we have never talked about this sort of, I mean, maybe we have, I don't think so. I don't think we've talked about this aspect of the climate crisis before. This is also from The Guardian, and it's from the 28th, October 28th. So I just found it like a day ago. But this is a really shocking piece of news, and I think it's a really interesting way to look at the climate crisis. We've looked at it through financial sort of means. We've looked at it through coordination technology. We've looked at it through, obviously blockchain. We've looked at it in all these different ways, but this is a historical perspective. So this is really amazing and unfortunate. It says, deluged by floods, America's oldest city struggles to save landmarks from the climate crisis. So St. Augustine in Florida was founded in 1565, apparently. I did some research on this, and it is, in fact, America's oldest city. I mean, 1565 is a really long time ago. We're talking like medieval times, I think. I'm pretty sure that falls in the medieval category. And unfortunately, Florida is suffering from floods. I mean, I've been to Florida many times because my best friend used to live there. And Florida has insane flooding on a regular basis. Just with high tide and just a regular amount of rain, you'll have 2, 3, 4, maybe not 4, but 2 or more than 2 feet of water in some areas. I mean, it's like extremely high. Like it would carry away a person. You wouldn't be able to walk through it. And there are fish swimming in the middle of the street in places like Miami. The fish come up through the high tide, through the gutters and everything, and then you just see them swimming down the street until the high tide goes away. Hopefully they go away with the tide. But anyway, St. Augustine is a historical landmark, obviously. It's on the northeast coast of Florida. It says it's the oldest continuously occupied settlement of European origin in the U.S. And of course, it's not that Florida has never flooded before. Florida flooded, in other decades or other centuries as well. But the rising sea level makes the flooding extremely severe, much more than it, used to be. It says on the weekend of 19th of September, last month, a combination of lunar and meteorological factors combined to sweep the sea onto the streets. St. Augustine experiences similar, although usually less severe, tidal flooding, often referred to as a nuisance or sunny day flooding, between 12 and 16 times a year. So I'm sure people will say, oh, but that's the moon, that's things we can't control, it's gravity. But when you have a higher sea level, because the hotter water expands, then what you have is that regular tide will happen, and then the tide keeps going further and further in because there's more and more water. And I know that, different places in Florida have invested insane amounts of money in seawalls, but, it's very hard to keep water out if it's surrounding a location. Obviously that's really, a difficult situation. But yeah, we're starting to lose these landmarks. So this is really sad. I mean, this is also happening in New Orleans. New Orleans is extremely historical, beautiful, very important, vibrant. I mean, it's an amazing place, but it's also really at risk. Places like Venice are also obviously, really at risk. And as here, according to the nonprofit sealevelrise.org, the waters around Florida rose as much as 8.59 inches. So that's, 3/4 of a foot between 1950 and 2016. And the rate of sea level rise is accelerating. So that means it's getting faster year by year. It says one city assessment predicted St. Augustine could face 1 foot of sea level rise in the next decade alone. Wow, that's insane. And as much as 3 feet of sea level rise by 2060 or the 2060s. So this is crazy. So, I mean, just so the people who are listening understand this, it says 8.59 inches between 1950 and 2016. So that's almost 70 years. And then it says, the city says it could face 1 foot. So that's more than double in the next decade. So that's like an extremely accelerated rate. And it's just really sad because, not to get into politics, and I'll give you a chance to respond here in a second, but, conservatives, they always talk about, conserving our values, conserving our historical sites, conserving statues, conserving, all, and it's like we're losing some of these like incredibly historic sites. I mean, obviously people will have different opinions about these places being, settled and stuff, but I thought conservatives wanted to conserve, so, I mean, just beyond, the need for nature, the biological need for nature, that human beings will die if we can't grow crops on Earth, obviously. There's also just this historical implication. So I'd love to know your thoughts on this.
Yeah, I think it's, clear that, like this article points out, let's see here, I'm looking for the paragraph. Oh, yeah, okay. So this woman, Athena Masson, a meteorologist for the Florida Public Radio Emergency Network, who is originally from St. Augustine, so she has an intimate attachment there. She says that while climate change isn't directly causing the floods, it is making them worse and more frequent. And she quotes, sea level rise is taking place. So of course, climate change is playing a role in these flooding events. So I think the idea that climate change is real and upon us and it is in fact anthropomorphic is being less and less disputed at this point. And it's part of the process. From the beginning of the current administration, it was a Chinese hoax, and now it's something that he just kind of wants to avoid directly talking about, but he's not making such crazy bold claims anymore. We've witnessed during these 4 years the decline of oil as the major driver of the economy, and even the largest oil companies are realizing this. So I think it's done. Like, maybe I'm hanging out in too much of a biased circle of friends, but I think it's pretty much understood now. Maybe I'm wrong. I mean, there's going to be deniers, always, but I think they're being pushed further to the fringe.
Yeah, I agree. I just think there's a big difference between the world, waking up and saying, oh shit, and then also like actually solving it. You know what I mean?
Yeah.
So there's a little bridge to cross there. But I mean, yeah, obviously every person who recognizes the severity of this and the cause of this is around the world. Around the world is another voice that we need to help us figure out the right solutions, and obviously there's never going to be just one. because the world isn't powered by one source, and different communities need different solutions. So we really need everyone, to be part of that.
Yep.
But yeah, I just wanted to bring it up because I just thought it was really sad, honestly, because we're losing these historic sites. And, I don't think that, we don't we don't want these places to become the next, Atlantis. I mean, I hate to paint it like that, but
well,
it's very hard to,
happen.
solve that. Once a city is underwater, it's a little hard to save, the artwork and I mean, it's just sad.
Yeah, it's inevitable because we've already passed the tipping point of that. So there will continue to be sea level rise even if we were to completely stop. So it's inevitable at this point. There will be cities that will be underwater.
Yeah, I mean, that's absolutely true. Yeah, it's definitely inevitable. Although I am curious to see like what technology might emerge in the next 10 or 20 years or the next 1 year that, might change the equation, if we get really good, what's it called? Decarbonization technology, that might help. Or anyway, yeah, I mean, I guess I'm praying for a miracle, but yeah, no, you're right. That, and Greg always says this, I think, is that, now we have to get into mitigation. We can't just, it's really about trying to minimize the damage because we know there's going to be a certain amount of damage, but, that doesn't mean that, there can't be more damage, right? So I think if we can try to minimize the damage that's already locked in, that will be good. But it's also kind of a catch-22 because people are just starting to realize how severe this is. But it's almost like even if people radically, if the world, I don't want to say radically changes, but if the world does change in a positive way, like in terms of how we get our energy and how we farm and things like that, which I think can definitely be done while maintaining our, lifestyles in certain aspects. Like maybe you don't get a cheeseburger all the time, maybe you eat something else, but that's going to be difficult because we're still going to have all these extreme events, we're still going to have a lot of problems for a long time with the climate. So I think there's a danger that people will think that these changes weren't worth it if they do get made or when they do get made, because I don't think that people can't always necessarily fathom how inhospitable this planet can be if we don't take care of it,
Yeah, it's a mindset that involves caring about not your generation, but the ones coming after you. That's why I always really appreciated the title of that James Hansen book, "Storms of My Grandchildren," because that's where his focus is.
Yeah, and that's so beautiful, and it does take, like, I feel a certain level, I guess we call it generational empathy maybe or something, but it does take a special kind of like thinking, I think, to really I mean, in both directions, right? Because there's the next generations, 2, 3, 4, 5, 10 generations after us, but then there's also the generations before us, and like how would they want us to take care of the planet? So it's like you want to be a steward of the earth for the past generations, but you also want to hand the next one something they can, look after.
Yep.
So yeah, generational solidarity. Not the easiest thing to cultivate in a social media world with the speed of TikTok and the speed of everything.
Yeah, it's interesting how we can be more connected and disconnected all at the same time.
Yeah. that never ceases to blow my mind.
Yeah, I read this quote about social media. It said it brings you closer to people who are farther away from you, and it brings you farther away from people who are close to you.
Ooh, yeah, that's it.
So anyway, yeah, Greg, did you have a chance to hear anything we were discussing?
Oh yeah, I could hear everything. Yeah.
Oh, great.
I'm just thinking maybe that might be a good segue for to kind of I remember last week it ended off at for me quite a kind of a cliffhanger.
Yes, of course.
And I'd be curious about picking up from there if you guys are interested in that idea.
Sure. Can you restore some context both for me and for our listeners?
Yeah. Okay. So at the end of the call, we were talking about RVote and how it could be kind of the skeletal backbone, if you wish, of a social network. The main core elements are there to kind of express sentiment, and it's easy, and so it's perhaps an exciting birth of an exciting next stage for RChain. And then near the end of that, you started talking about when you first were involved with the earliest incarnations of the internet back when it was still called DARPANET, and you saw the potential for how it would turn into something incredibly influential, and how there was this at one point there's suddenly a rush to kind of create value. And then we kind of left it at that, I think, pretty much.
Sure. Yeah. I mean, I think it is useful to go to look at the history of the internet, and to maybe apply some of the lessons learned to the development of new internet technology. I think that's a really important one. It's also interesting for me because back in the 80s, those of us who were using the internet, we could see what was going to happen to society, right? I mean, we were all communicating with each other, about the and it seemed like science fiction at the time, right? But we were all communicating, slide decks and papers, that it was going to be commercialized. But I don't think that the mainstream populace felt that way. Right? I think they were more they were like, well, I hardly ever use email. So that was it was an interesting transition, and then there really was essentially one catalyst, right? And that catalyst was the World Wide Web. And you could see it, right? Because as soon as people saw web pages and websites, then they were like they suddenly got the internet. Right? Suddenly it was real enough for them to go, oh, now I see what you're talking about.
Yeah, it's like, oh, I see pictures.
Yeah, mostly that. You're absolutely right about that. When a similar thing is about to happen with blockchain. Basically, the blockchain is the next iteration of the internet, but only if it scales, right? But it can happen, in stages, right? So first, people needed to see something like some kind of application like Bitcoin and Ethereum, but their imaginations are going to be really sparked when it will be as easy to build applications as it was to build a web page. Does that make sense?
Yeah, yeah.
Right, and essentially that's what we've been aiming for with RChain, is to make it so easy to build applications, and you know, part of the proof, you know, we were starting to see proof like with RSong, right? With RSong, well, you know, one of the things that was really beautiful about RSong was that it, you know, it took you know, basically 2 engineers 6 weeks to get the core thing running, and then we saw Luigi's group do proof using RChain, so they got their sort of crowdsourcing on the veracity of news stories, right? That was a new that was an offering that it took them 2 engineers about 8 weeks to get that going, and with RVote it was even simpler, right? Again, it was just basically not even 2 full-time engineers, right? It was just, you know, sort of, if you counted it in terms of full-time person hours, it, you know, wasn't even a person week, right? So that's that's part of the thing that makes that so exciting. It's just how simple it is now to build these high utility applications. So that's and again, the point is to look at it in that context, the context of building a you know, of the, how do I say, not recapitulating, but learning from how the adoption curve of the web. I think that's probably the simplest way to put it. Is that making sense?
Oh man, yeah, it's totally making sense. And Steve Ross Talbot has just joined us. So thanks for joining us, Steve.
Yay.
Yeah. So I have one question. You were talking about how the realization moment when people kind of came to realize that it was really easy to whip up a web page, learning some basic HTML, you know, markup language to, you know, just to throw up some pictures and some text onto a web page, and it was available for the world to see. And then you said we need to create, or we are at the point where we've created a place where it's just about pretty much as easy to whip up a application. So what I'm curious about is the idea that does the idea of an application replace the idea of a web page? And if so, doesn't there need to be some kind of unified platform like the World Wide Web, the HTTP protocol, that everyone would be able to uniformly use for the world to kind of function as a planetary thing?
Well, sure. That's what the blockchain provides, right? That's what RChain provides, is a platform, right, and a protocol.
So that when someone builds a dApp, and as opposed to a page on the web, I'm just curious about the kind of differences there. Like you build a dApp, you put it onto the RChain platform, and it becomes one of, you know, hopefully, theoretically, thousands or millions of dApps that are put onto this platform. And so I guess, does the DAPI browser replace the idea of a Firefox or a Safari?
I mean, sure, you can. The browsers are helpful and they are sort of give you a general purpose access mechanism to, right? Basically what a browser does is it gives you a general purpose access mechanism to the I mean, what is the web? The web is a giant distributed map of names to resources, right? That's what it is. Right. That's and in fact that's all it is. And then you know, so what we provided with, I mean, what blockchain is also a giant distributed map of names to resources. That's what, but where the web does as a protocol doesn't really allow for update, and certainly not transactional update, right? The blockchains allow for transactional update. That's the real shift, the real change.
Okay. So, a few days ago, maybe almost a week ago, you caught a good wave, and you were talking with some of us in a Zoom chat, and you were talking about how with the web there's been for over 25 years this technology where names have structure and there's correspondence between path and name, but with blockchain they have names to content, but they forgot about the structure part.
That's correct. That's right.
I'm trying to wrap my head around that a little bit.
Well, I mean, essentially, you know, names I mean, you've seen Ethereum addresses, right?
Yeah.
Right? There's no structure in them, right? It's just a long string of names. There's no like name.name.name or name/name/name. It's just a flat string. There's no internal structure that you as a user of these names manipulate.
Oh, okay. Yeah. Duh.
Yeah, so the names are like less like a URL, for example.
Yeah.
Right.
So, okay.
Yeah.
There's no kind of context to apply, and there's no way to kind of categorize or put things in a place.
Correct. And more importantly, there's no relationship between the structure of the name and the structure of the data that you access. Does that make sense?
Could you say that again? Is that fiber?
Sorry about fiber. I think someone's delivering something, and fiber's being protective of the household.
No, that's fine. Could you just say that last thing one more time?
So there's no. In addition, there's no relationship between the structure of the name. So like Ethereum addresses do have a structure, but it's not exposed or manipulable by a user of the address. But also there's no relationship between whatever structure it does enjoy and the structure of the data that you access.
Is
right?
Is this cutting to kind of like the key thing that that makes one of the things, at least, that makes RChain unique?
Yes. Yeah, I mean, it's in hindsight, people will go, "Oh my God, this was so obvious. Why did we miss this?"
Right. Yeah, because it seems like that.
but right now it's like this. It's teeth-pullingly hard to get people to recognize that you really need to have a relationship between the structure of the names and the structure of the data that you're accessing via those names.
Right.
So like, just so I understand, is it also like when you look for like a file on your computer, like you go to Finder, if you have a Mac, you go to Finder, and then like if you go deep into like your files, if it's like, you know, within a bunch of folders, like you can see at the bottom or the top that it like shows how you got there.
Yeah, so that path, right? So let's say, you know,
right, the path. Yeah, right. I've always enjoyed that
path, right?
Like,
the path gives you, you know, the literally the navigation through the folders, and then at the end of the path is the name of the file, not the contents of the file, but the name of the file. And then from that path with the file name, you can access those contents, right?
Yeah, I always thought that was really handy because if you have to go through 5, 6, 7 or more like, you know, files to get to something, then it's like, how could you possibly remember where it is? But if they tell you,
Yeah,
then
exactly.
you'll know.
Exactly. So there's clearly a relationship between the structure of the data on the disk in your machine, right, and the path name. And it's just something that we've known forever.
Yeah, it does seem so obvious when you say it like this.
And so, you know, what the row calculus does is it just acknowledges that relationship. It says, okay, well, there has to be this relationship between the content and the name, but it also addresses a bunch of other things, like, you know, like when someone puts some content at a particular name, and someone retrieves content at that name, you know, what constitutes the notion of transaction there, right? So, and that's sort of the COM event that you hear us talking about all the time, is someone putting and someone getting, you know, at the same name results in data transferring from the agent that's putting it to the agent that's getting it, right? But it brings together all the different pieces, right? The structure of the name, the structure of the data, and these transactional characteristics.
And that's what the row calculus does?
That's what the row calculus does. Yeah.
Huh.
It addresses all of those things.
Okay. So there was something else that you were talking about during that call. Thankfully, Raoul recorded it, so I've been revisiting it. And you were talking about the concept of isolation from there. Like, so if you were to have the structure, you can calculate isolation.
Yeah, that's correct, right? You can see, for example, that, you know, if, like in Nora's folder example, if you go down to, you know, a certain level in your folders, and then you branch off, then you have two names. One branches off to a folder called left, and another branches off to a folder called right. It doesn't matter what they're called. I'm just giving some useful names so that we can see that they're separate. Then as long as you have a discipline so that you don't put the same file in both folders, or if you were to put the same file in both folders, you would only ever be putting copies of that file, not the actual same file. So that you understand the discipline I'm suggesting?
Yes.
So whatever is in the folder called left, you know, it's not contained in the folder called right. So now you can just see from the path that you know, if I'm accessing path/left, and in particular if I'm updating a resource in path/left, that will have no effect on path/right. You can tell at a glance.
And so is that the element that opens up for concurrency? Because you can have two completely unrelated things running at the same time on
Correct.
the network.
Because no updates on path/left are going to impact anything on path/right.
Right.
So they can safely run at the same time without any problems.
Right.
So there's nothing magical about this. We've known about this for a very long time.
It seems.
Look, not 9 minutes to go, and I've been listening intently.
Oh, yay!
For a little while. So to bring it back to, you know, the web and the beginnings of the web. I mean, there were 6 or 7 projects in the early to mid 80s, largely in the USA, but not completely. And each of those projects was looking to solve a problem. And the problem was largely one of in each instance, they all had lots of documentation online, digitally available. Not in the formats we know now, but in the formats of that time. So when an AT&T engineer went out, for instance, to go fix an exchange, he'd have to go to a repository and pull out physically all the manuals so that he would be empowered to fix the exchange. Okay, and it would be matched to the job. And AT&T, one of the people that were working on these projects, Tim Berners-Lee over in CERN was working on another one. Identical characteristics. The problem there was scientists tended to publish in PostScript at that time, largely, or LaTeX. And when they published it, there were references. And Tim was thinking, wouldn't it be a good idea if you could click on a reference and it'd take you to the paper? That didn't exist, right? So that's what he was solving. And of course, those papers, like the manuals at AT&T, were multimedia in the sense that some of it was tabular, some of it was pictures, some of it was text, and there were lots of references. Meanwhile, back over on the West Coast, some guys had already got to grips with something called hypercard and hypertext. And I've forgotten the name. I think it might be Doug Engelbart. I'm not sure, but it might be Doug Engelbart that started that. And all of those 6 projects took lessons from that very early work, the very beginning of Apple, really, to understand how you could link pages together, just in the same way that we talk about linking pages in HTML. It all came from that. Now, when it started, I was on one of the 6 projects. At the same time, Tim was on his. I was on the AT&T one. And what we had all collectively wanted was not quite what we got when Tim was successful in getting all these bodies to back him. I mean, he was a smart political operator to do that. What he'd wanted was more, what he calls more semantics in the web. And by semantics, it was a loose term largely taken from the world of AI, ML, and automated reasoning. It wasn't taken from the perspective of Robin Milner, where in PyCalculus, you can send somebody a number, or you can send somebody a process that gives them the number. So this notion that data and process actually are the same thing. It's a big observation by Robin. And row calculus takes advantage of that, of course, and extends it further. But my point being is that the web was never really looking at behavior. It was really looking at static content. The idea of dynamic HTML came along a lot later out of need. And unfortunately, what they were doing was the classic case of bolting something on to an existing framework, which was the beginnings of the web with HTML and HTTP, and adding things that developers would use and actually use in ways that nobody expected. And so you get this birth of other scripting languages, JavaScript being one, to fix the problem. But what they're doing is adding more complexity to the whole notion that was quite simple of the web. Then along comes the marriage of blockchain, right, which is immutable, so you always have a record of the change, along with behavior, enshrined in at least RChain with Rolang and the row calculus. And now you can start reasoning, not just about the data, which was the semantic web. You can reason about the processes that might actually generate the data. So the universe of expressibility of things you can do in a type safe way, so there's no unintended consequences, in the world of RChain it's not infinitely larger, but it is orders of magnitude larger than what you can do with the web today, whilst retaining type safety. Full stop.
Exactly. And I mean, one of the things that's really beautiful is that the model is simple, right? You can fit it on a page.
You could actually pretty much take it. I've always had this idea of doing this as well. Maybe I'll do it with Roland. Well, with the row calculus. I always wanted a T-shirt where, on the top left-hand side, it would just have the basic calculus.
That's what we did actually for the for RDev 2.
I wish I had been there.
Boulder, or for DevCon 2, we did the T-shirt with the row calculus on it. They used the older syntax, the one from the original paper, which I'm no longer a fan of. But anyway, you can definitely do that. You can put it on a T-shirt. But to get back to your point, Daryl, about RVote. So the all of this history and context was to try to set up a reasonable discussion about RVote. So RVote is one of these apps that is like a web page, just takes literally a few hours to assemble. Most of the complexity is now in just making the user interface friendly and pretty. But the actual guts, the logic, the thing that makes RVote, do what it's supposed to do is very, very tiny. It's as tiny as a little bit of HTML around some content. And so that's part of what is making this so exciting, is that we've now provided this mechanism, and it's fundamentally different from Bitcoin and Ethereum and all the others, because the model retains all the lessons of the web and simplifies everything while dramatically extending the feature set. So that's kind of the idea in a nutshell. And then moving on, I know we've only got a minute left, but moving on from there, the point about voting is that, essentially when someone lends support to, a Twitter post or a Facebook post or an Instagram post or upvotes or Reddit post, all of those things are kind of like voting, in the sense that the underlying behavior that you would use to represent it is the same, or very similar. And so it can map onto the same smart contract or very similar smart contracts that are already written down in RVote. So, but if you wanted to be able to, run a smart contract for every post on Facebook, you would really, really have to scale. So at a minimum, you need the kind of scaling capacity that you have with RChain. But in truth, if you want to get up to, 1 billion users all simultaneously using the platform, you're going to have a pathway, a continuous pathway to scaling up and beyond the kinds of scaling that RChain currently does. And the architecture of RChain shows you that pathway. It tells you what are the pieces you need to improve, and even makes some clear suggestions about how to improve them.
So this was awesome. It looks like we're going to have to continue this next week as well, which is great. But thank you all. I'm sorry that we have to go a little bit suddenly, but we have a staff meeting. So thank you, everybody. And please subscribe to RChain on YouTube. You can become a member of RChain at rchain.coop. And if you'd like to be a guest on one of these future conversations, just write us at climate@rchain.coop. And thank you all. And thank you, Steve, for joining us.
Indeed.
Thank you, Daryl, for pulling me in. My clocks are out, so we changed ours.
Oh, yeah. Well, thanks a lot for coming. That was so good.
Pleasure.
Thank you.
Ciao, ciao.
Bye, everybody.